Hello, and welcome back. This is class number 4. Today, we have quite a bit of material to go through again, so I'm going to try to be as efficient and succinct as possible. So, that being said, let's get started. Essentially what I did is I started hammering out a key for this film footage, which has numerous challenges, as we noticed. The grain being certainly one of them, and then, of course, plenty of other issues surrounding it in the sense that the backing color is really closely related to the color of this woman's hair. That being said, let's just kind of go through a few things. The first thing that I did is experimented a little bit more with the denoise, and I do need to make a note. In the last class, I mentioned that it was kind of a render hog, which it is, if you don't have a GPU accelerated card. So if you have a computer with an NVIDIA card that has CUDA support, you're going to get much faster results. And so I just wanted to make a note of that. That's one of the new feature sets of Nuke 7 as well. So having said that, talking a little bit about the denoise, I felt that while I was experimenting with it, certainly early on, that I was not able to get very good results, especially between the red, green, and blue channels. And so I decided to do 3 different denoises for each channel and then add them together. So let me show you this process for which I went through. Previously, the denoise was giving us fairly muddy results, I thought. And so I was trying to back it off, but as soon as I would back off the amount of the effect, it would also create more grain in some of the other channels, and this is what led me to go this route. So essentially this here is the denoise red, and right here I am looking through the red channel, and let's just go ahead and set this to an even increment. One of the things about looking at grain is that it always helps, not only helps, but I would say it's almost imperative to look at the values of the grain at 100% increments. So whether it's 100%, 200%, and so on. This way the viewer's not trying to interpolate or give you some sort of, an estimated look. It's what you're seeing is the actual grain itself. So that being said, with the red, what I did is I went ahead and set the denoise off to the regular amount, and then I played around with the noise model just to see which was producing the best results. Ultimately, I felt that the noise model and the profile, when switched to their the non-default settings, produced less of the effect, but it actually brought more digital noise. So I decided just to shy away from that in general. Basically, what I ended up doing is, taking the denoise down and the roll off. Actually, I can't remember what the denoise default is at. Here, let's just take a look. I'm not going to destroy what we've done here just because I don't, whoops, not that one. Let's try one more time. Denoise, okay. There we go. So, okay, yeah, basically I took the roll off down. And then I didn't mess with any of the other stuff. I just find that the original luminance blend and chrominance blend from the past denoise has been very effective at allowing you to reduce the amount of grain in the shot. That being said, essentially what I did is I just took the luminance blend down and the chrominance blend down to give us this result here. So just looking at the two, you can see that there's a little bit of grain, but it really does kill the bulk of the grain in the red channel. Moving on to the green channel, well, actually the green's going to be very similar to the red. But if we look at the blue channel now, you'll see that it actually looks pretty decent. Now, you'll see a little bit of grain here, but it's not enough to negatively impact the key, so I felt. So what I did is just took it down as much as I could, and without making the hair detail feel muddy in the process. And that's what we have. Now that I've gone through that, and I showed you the approach for the denoise, the next step was to basically separate these out and recombine them. So If you haven't had a lot of experience with Nuke, this is a fairly basic technique, but just wanted to make sure you understood. So essentially, these are all shuffle nodes, and in each one, basically, I isolated the one channel that I wanted and then turned the rest to black. This is actually important. So that way, when we added the three back together, we have a denoise for each channel, but no other channel is polluting, adding the three channels back together. So that's basically what we did. And ultimately, if we look at the before and after, I think that's the before, but let me just make sure. Okay, here we go. So this is the before, and this is the after. And you can see that there is a marked difference, especially if we go through the various channels. And actually what I will do is hold the shift and the number 2 key, because that's what's loaded into my image buffer. Number 2 is the denoise. And when I do that, that brings up this wipe option. And now you can kind of see the various channels. So this is the red, this here is the green. And actually, if we gamma this down a little bit, you'll be able to see it more pronounced. And that's the red, that's the green, and then this is the blue, which of course is much darker. But essentially, this is what I was able to achieve from this process. Okay, moving on, let's talk a little bit about Primat. In the last class, one of the things that I was showing was all the feature enhancements with Primat 5, or what we have currently. And while I was showing them, a lot of these features were not really too helpful in our case here for this particular green screen. With this one, it wasn't really giving us the results that we were really looking for. So I just wanted to talk briefly about each of about the process that I went through. Ultimately, just to kind of fast forward to the answer, I found that the most effective new feature enhancement with Primat was using this hybrid edge, which I ultimately did use in my key. So we'll talk a little bit about that in the future, but basically just looking at the two previous example where we were looking at the lighting differences, I didn't feel that this lighting was going to help too much. Granted, we could have gone through, and I did actually try to experiment with some of the adjust lighting options just to see what it would do for us. But in the end, I just didn't feel that it was giving us the level of result that was going to be much more helpful. And another note about that, the fact is that this green screen, while it's a challenge to pull, it's not about uneven lighting that's making that difficult. It's actually more to do with the fact that it's not a very pure green, and more importantly, this woman's hair is very closely related with a lot of yellow, and there's plenty of yellow throughout the green screen as well. So having said that, I did look at what we could do with backing colors and how we could maybe produce better quality clean plates, etc. And in the end, I felt that these were not necessarily the best suited for the Primat keyer. So going through this experimentation process is, part of the how you do it, and ultimately I just found that some of the old techniques still work better. So yeah, basically the next step that I had to do was create a core mat, but I did it using the old method. So maybe I'll just kind of quickly demonstrate it. So Primat, here we go. And whoops, this is something that I always end up doing. It's where I branch a node off and then I grab the node and end up subsequently grabbing the noodle and disconnecting. But that aside, here, let's look at the Primat. So I got to say that the auto compute is pretty darn cool. I think that was pretty apparent from the last class, the example that I gave. And now it's just a click of a button. You don't need to sample colors. moving on, as we try to generate this core mat, the things that I'm going to do are just go here and just sample some of these dark areas. I'm not going to worry so much about the eyes. In fact, I have not done anything about the eyes in the comp, and that's just such an easy fix because you can just literally put a rotoshape in there and just track it. So I'm not even going to spend any time with that. But moving through here, we'll just kind of beef up our core mat a little bit. And obviously the biggest issue is to make sure that we don't have any of the backing color anywhere in our core mat. So just going through here, and let's bring some of this down so we can see what we're really missing in our foreground element, what's generating holes in it anyway. And just, sample, sample, sample. Okay. And I'm doing single pixel sampling with the, I'm not really marquee dragging through large swaths, because the reason for that is that it tends to give you less accurate results. And we want to get basically just the foreground in this particular case and no more. And the same applies with the background when we start sampling the background area. Okay. So that looks pretty healthy as far as a hard mat for the foreground. And let's go ahead and move to the background. So I'm going to just gain up a little bit. The background's looking okay. There's a few errant pixels here and there. Let me go back here to clean background noise. And let's see what we can find here. That took out quite a bit. And maybe we can also take out some of this material here. Yeah, okay. Let's see, what's that? I really am not concerned about holding on to any of the hair detail, because that's, in the end, it's just only going to hinder us in this process. And let's move down the line. There's, this. I wanted to get rid of some of this stuff too. Now that may be a little overkill, because I can see right now, having done that we just lost all the detail in our face and this center area. So we may need to go back and let's see what we can get out of this. Take care of some of this foreground. Actually, this is looking okay. Get some of these in here. And little single errant pixels like this are not going to kill us for the process that we're trying to go through. And actually, I think if I were to do this correctly, what I'm going to do would be creating a rotoshape and just taking this out. Because if we go to the original plate and look at it, and let me just reset the viewer. This yellow thing right here is what that is, and that's what I was trying to knock out. So that's something that would have to be taken out in the core mat. So that I haven't done that, but if you are going to take this, I would, when you're building your core mat, just take a rotoshape and just kill that instead of spending much time looking at trying to sample it away, because I think it'll probably do what we've been doing, which is kind of go around in circles. Okay, so now that I've done that, let's look at the mat one more time. Looking at it, and I'm not sure what... Oh, it's because I'm looking through the wrong node. Okay. So generally, this is how I create a core mat. And then the next step, of course, is to add a dilate, or actually an erode in this case. So just 1 pixel. This is the one that I had before. So this looks pretty similar to what we had. In fact, notice that I am using that new mask input to create a garbage mat for this stuff to knock out all this business over here. So now that I've kind of demonstrated the quick process of doing the core mat the old-fashioned way, obviously this is the part that we used to do, which is eroding it and then adding a slight blur. Now that we have that, we can go ahead and max this value with the edge key that I had pulled here. So that's ultimately what I got, was this key here, and that looked pretty decent. But moving on, one of the things that I wanted to also talk about is actually the experimental process of doing the IBK. So I did go through another IBK clean plate and subsequent key. And just another thing that I did not talk about with the IBK was, once you get a clean plate that you're happy with and you pull the keyer with the IBK, you have this red weight and blue weight, which will allow you to change the density of the mat. And basically I just took the red weight up a little bit to add some density to it, and then the blue-green weight to just kind of keep the values from going too crazy, especially in this hair detail. And ultimately it gave me what I thought was a pretty nice looking hair mat. And then the only issue, and actually let's go ahead and look at the output. So this here is the final output. My only concern was that it's a little heavy-handed with this soft mat that I got with the IBK. And let me just show you what I would do to fix that. And so yeah, I should be a little more eloquent here. Basically the switch node is designed for me to look at two different keys and just move back and forth between the two just by using my up arrow or down arrow. And so this here was the key that was done with the hybrid edge in the Primat, and then this is the one that was done with the IBK keyer. At this point, I wanted to make one little note about this class recording. I decided to edit throughout the video just to pare down not only the file size of the QuickTime movie that's going to be rolled out, but more importantly also to be a little bit more condensed with all the information that I was trying to get through. So you may notice a series of edits, but essentially all the concepts are still there. Now that we've done that, let's move on to another part of the tree, which is getting rid of some of the or actually getting some separation from the hair and that weird piece of tape, I'm guessing is what it is, on the backing screen. While I was experimenting with the keyers, I noticed in Keylight that when I allowed Keylight to do some despill, it created this really nice separation of this piece of tape in the backing screen and the hair in the foreground. So from there, if you look at the three different channels, you can see that the green has a reasonable amount of separation, but more importantly in the blue there's quite a bit more separation. So this gave me the idea to actually just run a key of this. So if we look at the output of this keyer, which is basically just running off of the blue channel, and here's the alpha channel, we got some of this nice hair separation coming through here. So I figured that's a great way to retain some of that in the key as well. From here is the next step, which is using a key mix node. The easiest way to do this is just to create a key mix. So basically this is an A over B operation, and I just noticed that I got a keyer, not a key mix. Let me try this one more time. Key mix. All right. So if you haven't used this node before, it's very simple. It's just A over B and then a mat input. So in this case, there's our mat. So if we plug that in, now we have this part of the key here. So now with that being said, let's take a look at the differences. And probably the easiest way to demonstrate that is just to look at the output. And if we come here, and this right here is our key mix, and we turn it on and turn it off, you can see we've removed a good portion of that, and yet we're still holding on to some of this hair detail. In fact, it's actually coming through better. And also, the other thing we didn't look at is the stencil from the channel merge. And actually I'll turn this off. This is with the stencil being applied. So it's a pretty significant change to the overall key. Now, that is basically the process for which I went through in key mixing. In this particular case, I was looking at the fact that I had this clean plate from the IBK Color, and then I just tried a simple difference mat. So here you'll see that there's nothing there until we look at the alpha channel, but once I did that, this started to pop a little bit more, and that's ultimately what I was trying to do, is get that so that it's more isolated, and then increase the value a little bit, and then use that to subtract from the overall key. This time another channel merge and setting it to stencil, and then using this rotor shape here to drive that, which I can see right now. Actually, we could stand to adjust north a little bit. This basically knocks this out to the point where that's no longer going to come through. So before, this is what it was, and now it's basically knocking that out. And then here is where it is. So if we were to turn this off and on, you'll see that it basically comes through in here, but now it's not going to come through in the final output or in the final render. So that's what I've done to create a key, and or at least work on generating the mat. Then the other step, of course, is that I essentially copied this mat into the within the RGB channels of the foreground element. So if we were to look at this, basically what I've done is all this along here in this pipe is all from various keyers, which I can tidy some of this up, which I actually will do that afterwards. And basically these are just starting with the basic key, then adding, in this particular case, going with the IBK, because that was just a switch. Then, now knocking out various pieces of the key that were, like in this case, that piece of tape on the backing screen, and then getting back some of the hair over the backing screen, and then of course that yellow dot that was in the backing screen as well. Now that I've moved the alpha channel into the RGB of the main plate, let's see what I've done as far as despill. So basically I've created two different despill methods here, and the first one I want to show is the expression. And basically this is without the despill, and then this is with the despill. And this expression essentially just says if it's green, if green is greater than red, then use red, otherwise use green. So in essence what that's saying is if the green value goes above the red, clamp it to the red. So then you'll be left with something like that. And quite frankly, if we wanted to, we could do another expression to clamp the green values to the average of the red and blue. So let's go ahead and do that. So if green is greater than red plus blue, and we need to put those in parentheses since those are 1, and divide that by 2, so that would be the average. Then, and I'm going to copy this because essentially the process is, then we'll substitute it with that, otherwise back to green again. And actually, to be honest, I kind of like this one better. So and you can see that there's a little bit of change going on here. Yeah, and actually here, if we look at, okay, yeah, honestly I like the other one more, because if we look at this one here, this is exactly the same as the key light, which that's another thing that I wanted to talk about. So basically we could actually substitute key light for another expression, or we could start tweaking on the key light a little bit. So but here, let me just go back and set this one back to just clamping to the red channel. So we'll just do red, There we go. Basically, I might actually adjust some of the key light despill. So if we look at this, the first thing we can do is take our screen gain down a little bit. And that will minimize some of that. And I'm going to go ahead and compare between the two. And then also what we can do is take our screen balance down a little bit. So now we should be able to get some of that despill without affecting the skin tones as much. So yeah, and honestly this is looking pretty decent. So I think that I might just leave this for the time being. But that being said, the next thing that I wanted to, so what I did then is taking this expression here to get this, to get the interior part, I decided to take the core matte that we had previously and erode that significantly so that we're cutting into it and then blur it out. And in doing so, now if we look at the difference between the foreground the untouched original plate and the despill that I've done, if we compare the two, you'll notice that there isn't much going on to the interior of her face. And ultimately that's what we wanted to make sure, is that we're not changing anything on the inside. It's only just the area in the backing screen that's being adjusted. So that is essentially the process that I went through for just despill, which in this case is not too complicated, but for me, I gotta say, my favorite quick and dirty usage of the despill is just taking a key light and setting one in the green channel or the blue channel if it's a blue screen, and letting it run its own despill algorithm. And then, it's nice to have the expression and know about these, the two that I just showed. But this certainly saves a lot of time in the process. So essentially, that's where we are at this point. And I also wanted to show basically what I usually do, which is that when I have my matte coming in on this channel here, and I copied it in with the RGB channels of now our despilled plate, I usually use an add mix. And the reasons for that is because for default, the add mix comes in as a unpremultiplied A over B, and this is exactly the same as a key mix. The reason why I like the add mix is that it actually gives you the ability to blend the edges of things like hair in cases where you're just trying to pull a quick key and get it to sit in nicely. So as you can see, I'm adjusting the curves now for how it's being mixed in, and immediately it starts to give you some almost better results. But in my case, I actually left it at default, but that's to taste. So I would say if you want, play with those, but it's not a big deal. But having said that, this does give you a little bit more extra power at the end of your comp, which is nice. Now, one last thing that I wanted to show is this other process here, which basically what I decided to do is multiply in the chroma and luma values of the background onto the semi-transparent areas of the hair. And in doing that, it makes it feel like it's actually sitting in much better. A lot of times people use a light wrap, and I'm not a huge fan of the light wrap because, well, frankly, a lot of times it looks like a light wrap. And this process here is actually pretty cool. So let me demonstrate that. Looking at the original plate and comparing against the despilled plate, if we subtract the original plate from the despilled plate, you have something that looks like this, which with our LUT turned on, you can't see much. In fact, I'll gain this up. What you see here is actually a spill map if you will. So it's just showing you all the areas that are being affected by the D-spill. And when you have that, what we want to do is actually multiply this with the chroma and luma values of the background. In doing that, that means your edges are actually going to feel like they're actually in the scene. So basically, moving forward, the idea is to take this map, and now that it's we have this essentially isolated, what we want is to turn this more or less gray, because we don't want any green coming through in our process. We just want the gray value of it. So the next step is to create a saturation, or a desaturation, if you will. So looking at that, I basically removed all the color from the spill map area, and then moving over to the foreground, I'm going to turn this off and look at the original foreground here. The idea is to blur out the foreground, so just blur it so you don't see any detail, and I figure this is certainly enough for what we're trying to do. Then add a luma keyer, which, you know, by default is just going to take the range of luma values through the plate and then unpre-multiply that by itself. So when you do that, you're left with this really hot looking image. Now the reason for doing this unpre-mult, is that this divided by its alpha channel then raises it to the point when you actually multiply it, it's not going to bring it down below, it's not going to bring values down. So the gray values are going to stay at roughly the same gray values that they are here in this section here. So having said that, when we multiply that together, I'm going to one more time crank on this. If we look at before and after, you can see this gray value is now taking on some of the value of the background. And then if we just add this to the original despilled plate, then you are left with something that looks like this. And let me just take that off. So here you can now see that it's taking on some of the values of the background. And with that, let me just show you the final output. And this basically makes a big difference. And I'll turn on the lighting again because that does help. Oh, and actually, I've been running into some issues with the input process recently where this... Alright, let's see if we can step through one more time. Hopefully that won't... Yeah, but I noticed this earlier, so I'm not sure if that's a bug, which it could very well be. There we go. And, look at this, look at this. Well, now we're okay. Okay, so yeah, I'm pretty sure that's a bug, because the process of getting that to come back and be visible wouldn't work otherwise if it weren't a bug. Okay, now that I've done that, just wanted to show the end result. So this is what it was before. So you have this kind of orangish stuff, but if we add that together, now it actually starts to feel like it's mixing in with the background much better. So that is basically the process of how I'm putting this key together. A couple other finishing items that I wanted to discuss was the background plate. This was just material that I had shot a while ago that, you know, doesn't have any meaning to it, but I just figured it would work with what we're trying to put together, so that's why we're using this. I went ahead and blew it up slightly, and the reason for that is because we have a camera move in the original shot, which I tracked and then match moved the plate now with this match move here, and this is generated from the tracker that we ran. And then the other thing that I wanted to do is just to get this to kind of balance a little more with the foreground element. I decided to warm this up considerably because previously this just really felt awkward. So now moving this together, now it looks more like she's under a sunshade with some hot light on it. But now it's feeling like it's mixing with the background a little bit better. And one other thing that I have not discussed is the process of grain management. So we definitely want to add grain to this, because obviously in this plate here there is a ton of grain. So let me go through that really quick. This knot right here is the all the way from the what do you call it, the denoised work that I did earlier. So moving back over here, let me come back. I have added a grain node to that, and then a key mix to the original plate. So this is the original, this is our denoise, and then this is our grain being key mixed over. Now the reason for this, which I'll show you here, is basically I've created a hard map, and since the grain's been removed, I'm adding grain back on top. Now you can see very quickly the differences between the grain and the non-grain. So you can see the grain changing slightly, but this is a good way to determine whether or not your grain is matching well. So I'm going to go ahead and turn this off so you can see it. But essentially, taking the grain node, if we were to reset all this, so if it comes in normally as 5248, if you look at this, you'll notice, actually here, let's do this. Let's break this away from the control panels so we can actually see more real estate, and let's set this to 100%. Like I was saying earlier, 100% increments are definitely key when it comes to grain management. So looking at the red, you can see right away that this is just crazy, but we can take this down. I think I had actually figured it out to be about 1.9 was the size, and then take the slider down to match in nicely. And then the same applies for the green. I think we'll just keep the green size all the same because it probably works pretty well. So now you're seeing a little bit of this grain in here, but it's not overpowered. And then the blue, which the blue actually looked pretty good, just right out of the gate. And actually, if we gamma this down, it looks like it's a little intense, and I would just take that down ever so slightly. And actually, the other thing I want to do is just show you what happens if we were to remove the grain. This is now the difference between having the grain and not. So you can see right away that this grain is now working very well. This, to me, is my favorite way to match grain, because you see right away whether or not it's going to work. And now that we have that, you can just literally copy it. And, one thing I did forget to mention, which is important. When you add a grain node, by default, it has this checkbox applied. When you do that, of course, you won't see anything unless you have an alpha channel piped into this grain stream. And realistically, we don't want that. We just want to grain the entire thing and then just use this as our mat to determine what's grain and what isn't. So now that I've done that, we can copy this and apply this to the background. So now, at least this will feel grained together, so that it's not like a grainy image over a smooth image, rather. So now that we've done that, you can see, and actually one more time, going back to 100% increment, you can see the differences. In fact, the one thing that's interesting is that the grain feels a bit heavy-handed, and it could be because, In fact, yeah, I would actually tone, in this particular case, I would tone this back. And, you know, the easiest way to do this, just we'll run a dissolve. And now we can just fade the grain down because I think it's pretty uniform. So now if we run this, you can see very quickly that we're going to get, and one more time, let's go back to the 100% increment. So we can see, it's natural for me to want to frame to the viewer and see more of the image. And we'll break this out of the control panels. So we can now fade this. So this is at 100%, and honestly I'm thinking that I like this more. So while I showed you the graining technique, it does work, but in this particular case, for some reason it's feeling a little heavy on the image in the background, and it could be just the luma response in that image is so different, and that's why it's looking so heavy. But that being said, let me render this out and let's have a look. Basically at this point, this is the render that we have from the key that we did, and this was using the IBK from the switch node that I had showed earlier. Now, one of the reasons why I left that switch node in was so that we could render another version and compare the two different clips in FrameCycler. So this is one of the things that I wanted to show off, because I know a lot of times people have great difficulty using FrameCycler to their benefit, for that matter. So starting with this flip book, you can see that it looks pretty decent, but more importantly, let's take a look at this with actual LUTing on it, because what we were looking at was the logarithmic plate. So, and the calibration's left off. But if we switch this from Nuke Cineon to sRGB, this now is with, you know, what you would normally expect. And having said that, let's also look at something else, which is how you would view this with a mask on it. So over here we have a couple of different options. You have the crop, which basically we can literally crop and mask off the image according to 1:66:1, or if you wanted to put in a mask, which is like a just basically a grid line, you could see it. So for example, if we wanted to do maybe not 2:35:1 but 1:85:1, you now can see how that looks against the original against the 1:66:1 mask as well. So those are two things that I wanted to show. And then lastly, the most important thing that I wanted to show was how you would bring in another clip and compare it against the compare it with a wipe. So having said that, let's take a look. I'm going to go, as you can tell, I'm using the Mac OS, but the same applies for Windows. You can literally just drag your directory, which has your sequences in it, into the viewer of FrameCycler once you have it up. So literally you can just drag this in. When you do that, it immediately, you can see right away that we have, I actually have the wipe set up, and I shouldn't have, it's because I had already set it up earlier. But typically by default, it's going to come in like this. So it's going to be a side by side, and to get it to wipe, you need to go down here where you see this little tic-tac-toe matrix, if you will. And from there, when you have these two clips up, if you set this to split, then you will get this split. And you can tell right away, since we have calibration off on one and not on the other, you can see the wipe very easily. So I'm going to demonstrate that, because then the next thing that you need to do is hold down. In some cases it's the shift key, and in other cases it's the command or control key, depending upon if you're on Mac or Windows. So I am holding down the command key and just hovering over, and you can see that I'm able to drag between the two versions very easily. Now, if I wanted to actually compare apples to apples, I would set this calibration to Nuke Cineon to sRGB, and then you can see as I move over to the right-hand side of the screen, you can see the hair changing from one keyer, the Primat versus the IBK, if you will. The other thing that I should also show is the tab key will get rid of all the timelines. So if you want to see the whole canvas without the timelines getting in the way, you can hit the tab key like so. Now when you do that, you can also see at the top of the bottom of the image, there's a little caret right here that shows the wipe handle. And now you can see the differences between the two. So if we wanted to just play this now, I can literally play while it's and wipe while it's playing, and just quickly scrub through and see how it looks one versus the other. So currently this is the this here is the one on the left is the IBK, and then the one on the right is the Primat with the hybrid edge. So that is really what I wanted to show in FrameCycler. Oh, and one last thing, which is also very useful, is this origin here. So I'm actually going to get rid of this. And by the way, the manner in which you get rid of it is just grab here and just drag, and it will go away. Now, the last thing that I wanted to show was, if you notice your playhead here, it says frame 36, and it starts at 0. It's not going to represent frame 1036 in Nuke, because you are starting at frame 0, so it's going to be one frame off, and then of course 36. What if you want to just see exactly what frame you're on? Well, you just set your origin to the timeline view that you have in Nuke. So in this case, we have it set to 1001 is where it starts. So now, when you do that, you can see right away that the playhead automatically switches to the frame number that you want to be able to reference. And this is pretty helpful given the fact that so often when we're going through and flipbooking our work to see where there's where we need to make changes, if you don't know exactly what the frame number it is, it's kind of a pain. So I hope this is helpful to you folks, because I know for me it's been very helpful to try to sort all these kind of technical issues out with FrameCycler. And that being said, let's go back over to the script here, and we'll talk a little bit about what else is going on. So before I send this script out, I'm going to go ahead and clean it up so that it makes sense. Over in here, I will delete all these nodes. These are from the previous script from the class 3 video that I was going through. And then lastly, what I did is I also brought in another piece of footage, which was a photograph that I shot. And basically I'm taking it from log to lin, or lin to log, so that the color values are in the same color space as everything else. And of course it's been sourced in as raw. So with that being said, if you want to play with two different pieces of footage, I would invite you to do that. You have this and now this. And then also, if you wanted to try pulling a key, I would say on either the Red Epic footage or the Canon C500, give it a whirl. And you know, one of the nice things about the Red Epic footage and the C500 footage is that you won't have the issue with the grain, and it will be much easier to pull a matte. I just went ahead and created two different keys from Keylight. Just by having the log to lin and the raw plate, I was able to get two very different mattes just right out of the gate. And this is not doing anything fancy. This is just sampling the backing color. So this here is the raw, and then this is with it being converted from lin to log. So if you look at the differences, you can see right away you can get very different edge detail if you want, and that sort of thing. So there's something to maybe think about if you're going to pull a key on this, to use one as more of a core matte and the other one is more of an edge mat, and to see what you can build from there. That being said, I think this is essentially what I wanted to convey, and if you have any questions, by all means submit them on the forums and I will respond as soon as I can. And most of all, thank you.